Okay, let us now continue with the second part of the problem. You remember the previous problem was for 5 marks out of 15 marks. This is the second part of the problem. Anyway, let us try to do this within 5 minutes. Okay, the wave moves from region A into region B of shallower water. Okay, there is a wave which is being given like this over here. The waves moves more slowly in region B. This is region A, this is region B, which means what? The speed of the wave here, let me call this as something like C2 here, and let me call this C1 over here. This speed is larger than this one. C1 is greater than C2, which means this is your rarer medium, this is your denser medium, right? Okay, and then what else is given? A diagram has some wavefronts in the region A. Wavefronts are given. How are the wavefronts given? Wavefronts are always perpendicular to the rays. See, this is your ray, this is your wavefront. Okay, what is he asking us to do? On the diagram, draw 3 lines to complete the wavefronts in region B. So you need to draw the wavefronts over here. So it's quite easier for us to draw the rays instead of drawing the wavefronts. So first what we will do is we will first draw the rays over here. So towards it, so let me extend this ray front so that it attacks this surface like this. It joins the surface like this. So if this is my 60 degrees and this is my 90 degree, what should this angle be? This should be 30 degrees over here, right? Then what I do is I draw a normal. Now how do I write the angle of incidence? If this is my incident ray, then this should be my angle of incidence. This should be my angle of incidence 60 degree. Then what will happen? Since this velocity, this is your rarer medium and this is your denser medium here. See, this is my rarer medium and this is your denser medium. So what can happen now? So as a result of it, the ray here will bend towards the normal. Ray here will bend towards the normal like this. This will be a ray, refracted ray. Now how do I draw the wavefronts for this? The wavefronts for this would be written like this, perpendicular to the ray. It will be written like this. Since it's a denser medium, we know that in a denser medium, velocity is lesser. If velocity is lesser and this is the wavelength, between two lines is the wavelength over here, this wavelength should also be smaller. It should be smaller here. If this is smaller, then what does it mean? That means now I need to draw. So this is my correct wavelength. Okay, but I need to draw this extending this line. So how do I draw here? So what I do is, now you see, I take the same line and put it over here. Okay, drag it here like this. And if I write like this, parallel line similar to this one, see, similar to this one, like this over here, like this over here. See, this largest wavelength, this smaller wavelength, and this will give you the refracted wavelength. See, what is the condition for refracted wavefronts? The wavefront seen here should be parallel to this one. Okay, so that's what we have done. So therefore refracted wavefronts are being drawn over here. So now this is for 2 marks. When you say for 2 marks, I have drawn only 1 mark for here, which is the other mark going here. If this is 60 degrees and if this is, what is this angle? This is your angle R, which I do not know what's the value of R. Okay, therefore now this will become your R. I am not asking you to find out the value of R, so just mention the value of R over here. So this gives you the refracted angle, right? Let us move on to the next one. Series suggests that the wave speed C is related to the water depth D by C equal to root GD. C is a velocity, G is some constant, D is nothing but the depth. The refractive index is given over here. Determine the following ratio. Water depth in A by water depth in B. So if I take the ratio here, CA divided by CB is equal to root of G into DA divided by root of G into DB. GG cancels away and I get this. Now, what is the need for taking this? What is given here? Refractive index. What is refractive index given by? Refractive index 1.4 is equal to velocity of the rays in the first medium, rarer medium, to the velocity of the rays in the second medium. So therefore, this is already given. So let me substitute here, which will now give me 1.4 is equal to square root of, let me scroll it down to have a better look over here, dA divided by dB. So dA by dB would be 1.96. When I square this, I get the 1.96. Since I am using only significant figures, so I should get the answer as 2.0. Thus I give the answer as 2.0 here. Okay. Now we have finished this in 5 minutes. Let us do the next ones also if possible. Another sphere is dipped into the water. The spheres oscillate in phase. What do you mean by in phase? Okay. Now you have 2 spheres which are now doing some oscillation here. The diagram shows some line. I don't think I'll just continue this video in the next video itself. This problem in the next video.